Let's start with some definitions and some general classifications. First, let's define the stationary phase, which can be said as the immobile phase that's somehow bound to the inside of the column. An important thing to note here is that it doesn't have to be a solid as long as it is fixed in place inside the column. The next thing we need to define is the mobile phase, which is the fluid phase that mobilizes the analyte through the column. Now this fluid can be anything that is fluid, a liquid, a gas, a supercritical fluid, etc. And separation arises from the differential interactions of different analytes with the mobile phase and the stationary phase. When we talk about classifications, things get a little more complex. We can think about the distinction between column chromatography or planar chromatography, where column chromatography is where the mobile phase is forced through the column in some way, perhaps pressure, gravity, or electric field, and planar chromatography, which typically uses capillary action or gravity, like TLC. This classification scheme is not nearly as useful as it could be because the principles are the same for the two. So in this class, we'll focus on another classification scheme. In this classification scheme, we'll categorize the separations based on what their mobile phase is. For example, gas chromatography, which uses gas as its mobile phase, and liquid chromatography, which uses liquid as its mobile phase. Oftentimes, you'll also see various electrophoretic separations classified as types of chromatography, but as we'll learn, they don't count as true chromatographies because of the nature of the mechanism of separation for those types of separation methods.